Let's begin with one of the most common interview questions. What's the difference between props and state in React? Props are external inputs. They are read-only and passed from a parent component to a child, just like arguments in a function. The child can use them, but it cannot change them. This ensures React's one-way data flow, where updates always move downward from parent to child. State, on the other hand, is internal and changeable. It belongs to the component itself, and it can be updated using React's state functions. Whenever the state changes, React automatically re-renders that component to keep the UI in sync. Think of it this way. Props make components reusable, while state makes them dynamic. For example, in Uber's app, the parent map component passes the driver's live location down as props. Meanwhile, the ride timer, counting how long the trip has lasted, is managed as local state inside the ride component. The key takeaway? Props are controlled from the outside and never change internally, while state is controlled from within and updates over time. Now let's move on to another important concept, lifting state up. Sometimes multiple components need the same piece of information. If each one manages its own copy, you'll end up with duplication and inconsistencies. Lifting state up means moving that data into the nearest parent component so it becomes the single source of truth, and then passing it down as props. The process works like this. First, identify the shared data. Second, find the closest parent that can logically own it. Third, move the state into that parent and pass it down to children. For example, in a temperature converter app, you might have one input for Celsius and another for Fahrenheit. If each input stored its own state, they could get out of sync. By lifting the state into a parent component, both inputs always reflect the correct value and update together. In interviews, explain that lifting state up ensures consistency, avoids duplication, and is usually the simplest solution before introducing more advanced tools like the Context API. Next up, let's talk about React Fragments. By default, React components must return a single parent element. Many developers work around this by wrapping elements inside an extra div. But those extra divs clutter the page, make the DOM heavier, and can even break layouts built with Flexbox or Grid. Fragments fix this problem. They let you group multiple elements together without adding unnecessary nodes. You can use the full React fragment tag or the shorthand version that looks like empty angle brackets. Both work the same, but the full version can also accept a key prop when rendering lists. The benefits are clear. A cleaner DOM, fewer nodes for the browser to process, more flexibility with CSS, and semantically correct markup. Here's a real-world example. In a Facebook post, the comments and reactions are rendered side by side. If you wrapped each section in an extra div, it could disrupt the alignment. Using fragments keeps the structure clean and the layout consistent. So in interviews, emphasize that fragments are a simple tool with a big impact on performance and maintainability. Now let's discuss a conceptual question interviewers often ask. What's the difference between React's createElement function and JSX? JSX is a special syntax that looks like HTML, but is actually JavaScript. When you write JSX, it gets compiled into createElement calls under the hood. For example, imagine writing a button in JSX with the text like and a primary style applied. React automatically compiles that into a createElement call, which produces the same button structure in JavaScript. Why is JSX the standard? Because it makes your code more readable, easier to maintain, and better supported by tools and editors. JSX also allows embedding JavaScript expressions directly inside curly braces, so your UI can adapt dynamically to changing data. Think of Netflix's interface. Their application contains deeply nested UI components. Writing all of that using only createElement calls would be nearly unreadable. JSX makes the structure clear, intuitive, and manageable. So the key point is this: JSX is not required, but it's what makes React development productive and scalable. Let's now look at the rendering lifecycle in functional components. In the past, class components had explicit lifecycle methods, things like component did mount, component did update, and component will unmount. Functional components don't have those methods, but hooks provide the same functionality in a more flexible way. Here's how it works. On the initial mount, React renders the component for the first time. When props or state change, React re-renders the component. When the component unmounts, cleanup functions run to release resources. The useEffect hook is the key tool here. With no dependency array, it runs after every render. With an empty array, it runs only once, similar to component did mount. With specific dependencies listed, it only runs when those dependencies change. And if you return a cleanup function, that code runs just before unmount, like component will unmount. Here's a real-world example. In a weather app, when the user selects a new city, useEffect triggers a fresh API call to fetch updated data. The cleanup function cancels the old request to prevent leaks or race conditions. So in an interview, you'd explain that hooks replace class-based lifecycle methods with a cleaner, more predictable approach. Finally, let's cover the two most essential hooks in React: useState and useEffect. useState adds state to functional components. You give it an initial value, and it returns the current state along with a setter function to update it. State updates are asynchronous and batched, meaning React optimizes them to avoid unnecessary re-renders. useEffect is for side effects, work that happens outside of rendering. That includes API calls, setting up subscriptions, managing timers, or updating the DOM manually. Effects run after React finishes painting the UI, so they don't block rendering. You can control when they run by using a dependency array. Forgetting dependencies is a common mistake that can cause infinite loops. Here are some typical use cases: fetching data, handling form inputs, setting up event listeners, or managing animations. For example, in a YouTube player, useState might track whether the video is currently playing or paused. Meanwhile, useEffect keeps the progress bar synchronized with playback time, updating every second. A cleanup function stops the timer when the video ends or the component unmounts. Together, useState and useEffect form the backbone of modern React development. They replace most class-based lifecycle methods and give developers a much more intuitive way to manage component logic. Let's quickly recap what we learned in this part. We started with props versus state, the foundation of React data flow. We explored lifting state up, which ensures a single source of truth. We covered fragments, which keep the DOM clean and efficient. We compared JSX with React's createElement function and why JSX dominates. We walked through the lifecycle of functional components, managed with hooks. And finally, we broke down useState and useEffect, the two essential hooks every developer must master. If you can explain these concepts with clarity and real-world examples, you'll be well prepared for React interviews. Now, if this was useful, don't forget to like this video, share it with fellow developers, and subscribe to the channel for the next part in the React Top 30 interview question series. And be sure to hit the bell icon so you don't miss part 3, where we'll dive into advanced hooks and the context API. Thanks for watching, and I'll see you in the next one.